So hi everyone. So in today's session, we will be diving into the ESP32 microcontroller, so which is developed by the Espressif Systems. The ESP32 is a powerful, feature-rich microcontroller known for its wireless connectivity capabilities, so making it an ideal choice for its IoT applications. So let's start by discussing its pin description, applications, and different types of ESP32 boards and the various programming languages it supports. So let's start today's session. ESP32 microcontroller. The ESP series having an inbuilt Wi-Fi and Bluetooth modules on it. So these ESP32 microcontrollers are having the onboard Bluetooth and Wi-Fi modules. Okay. So we have different types of ESP32 microcontrollers versions. So when coming to the key features, so why we are going to select the ESP32 means it having the various features. So it have a dual core processor, and along with it have an inbuilt Wi-Fi and Bluetooth module. So it supports 802.11. So it supports the both Wi-Fi and Bluetooth, and which makes it more suitable for the wireless communications and in the IoT applications. And along with this inbuilt Wi-Fi and Bluetooth, so it having the feature of low power consumption. So because of this low power consumption, so we can use this ESP32 controller in various applications. So we can operate it with very low power. So these ESP32 is designed in form for battery powered applications. And it will also contain some rich sets of peripherals. So like this ESP32 have wide range of peripherals, like, so it will provides us the ADC nothing but analog to digital converters, digital to analog converters. So it will also provides the PWM, like piles with modulation. It will also gives us some communication protocols like SPI, I2C, UART. So UART is nothing but universal asynchronous receiver transmitters. So all these actions are, so we can access by using the ESP32 microcontroller. Okay. So these are some key features of the ESP32 microcontroller. Like the microcontrollers, so we have the different ESP32 families. So the first one is ESP32W Room 32. So this is most commonly used module in the ESP32 family when compared to the other family versions. So it includes the system on chip and a 4 MB flash memory, and is ideal for general IoT applications. So if we want to work on some general IoT applications, so we will use ESP32W Room 32. And the next family is ESP32W Rover. So this Rover module is similar to the W Room module, but it includes additional 4 MB of external RAM. So the first family doesn't contain any external RAM, but in W Rover we have an external 4 MB of RAM. So because of that, so it is suitable for application that requires higher memory, such as like video processing or image processing. So in those applications, we will use this ESP32W Rover family. This is the image of ESP32W Rover 32. So it is containing the external 4 MB RAM. So because of that, we can use this module in the applications like if we want to stream the video or in image processing applications, we use this W Rover board. So the next type is ESP32S2. So this is a single core version of ESP32. So it offers a low power consumption with improved security. So this type of board, like this ESP32S2 board, so we can use this board for the applications, so where we need the high security and low power, such as like wearable devices, we can use this S2. So it will provide the low power consumption and high security. Okay. So next, if we come to the next family, that is ESP32C3. So this version features a RISC-V single core processor, and this is also focuses on low power consumption, so while maintaining the Wi-Fi and Bluetooth support. So it is designed to support the applications where low cost and simplicity are needed. So if we want the low cost and if we want a simple microcontroller, so we can choose this ESP32C3 microcontroller. And the final type of ESP32 family is ESP32S3. So this ESP32S3 contains an enhanced AI capabilities. So including the vector extensions and support for voice recognitions. So whenever if we want to enhance our AI requirements, so we can go with this ESP32S3. So it is ideal for applications requiring the AI. So wherever if we want to use some artificial intelligence, so in those cases we will go for this ESP32S3 microcontroller. So which is one of the best microcontroller family from the ESP or Espressif Systems for the AI applications. Okay. So this is all about the different ESP32 family versions. So among these boards, so this is the board we are going to use in our course. Okay. So this is a simple ESP32W room board. So which is most suitable for the IoT applications. Okay. So this is the pin description of this ESP32. So this ESP32 has a rich set of GPIO. So GPIO nothing but so general purpose input output pins. So these pins so that can be configured to serve the different functions. Okay. So these GPIO pins, so we can use these pins to connect some input and output devices with the ESP32 microcontroller. And here we have some power pins. So power pins, like here we are having some 3.3 volts, right? So this is the regulated 3.3 volts output pin. So which is used to power the external devices. Okay. Along with this, we have some VIN. So this is the input voltage pin. So where you can supply a voltage between the 5 to 12 volts. So from here we will get the 3.3 volts, and from here from this VIN, so we can supply a voltage between the 5 volts to 12 volts. And next we are having some ground pins here. So these ground pins, so we have here 1, 2. So we have, so here we have 2 ground pins, right? So these ground pins on the board that serves as a reference voltage to the circuit. Okay. So next, digital IO pins. So GPIO from GPIO 0 to GPIO 39. So these general purpose pins can be used for digital input and output. So they can also be configured for specific functions. So such as PWM and for UART, I2C. So if you observe, so these GPIO pins also having some specific functions like ADC, and we are having some touch pins here, and UART for I2C. So for I2C, we will use some SDA, SCL pins, right? Okay. So when coming to the analog pins, so analog pins, so these ADC pins, so these ADC pins are nothing but the analog to digital converters. So it will contains nearly 18 channels for 12-bit ADC. So these ADC pins gives us the 12-bit ADC operations. So these are used to read the analog signals, and after that they will convert it into digital signals, right? Along with that, we have some UART pins also. So here if you observe the TX RX pins, so here we are having the TX D2, RX D2, TXT0, RXT0. So these are the examples for the UART communication pins. So these supports the universal asynchronous receiver transmitter, right? UART means. So these pins are used for the serial communication. So it supports the 3 sets of UART pins. Okay. So next, and along with this UART communication, we have some serial peripheral interfaces. Okay. Serial peripheral interfaces also present. Like, and along with that, we have some I2C pins. So it has two I2C channels for the communication with the multiple devices using only two wires like SCA, SCL. So these are the I2C pins we have available in this ESP32 board. And along with this, we have some touch pins also. So like from touch 0 to touch 9. So these are in green color, right? So these are the touch pins. So from T0 to T9, so which can be used to detect touch and ideal for touch sensitive applications. So these will detect the touch of the device. Okay. So along with this, we have some other important device pins like enable. So this pin is used to enable or disable the total ESP32 board. So when this enable is pulled low, the board goes to reset mode. Okay. And so with this, the pin description of this ESP32 board is completed. Now we will see some main components of ESP32. So let's look at these key components found on the ESP32 board. So it has one system on chip. So at the heart of the ESP32 board, so it is the ESP32 SoC, so which integrates the CPU, Wi-Fi, Bluetooth and other peripherals into one chip. So this SoC provides the processing power and connectivity for the board. Okay. So next we have some flash memory and we have the USB to serial converter. So this chip is responsible for converting USB signal to UART. So allowing you to program and communicate with the ESP32 through the USB connections. So this USB input is used to dump our code into this ESP32 from our computer. So by using some USB connection or USB wires. So from this point we can dump the code into this ESP controller, and we have one voltage regulator over here. So this voltage regulator, so commonly it is a 3.3 volts regulator. So it ensures that the ESP32 and its components receive a correct operating voltages. Okay. So it takes the input from the VIN and it will do the step down to get the 3.3 volts. Okay. And here we are having one antenna. So this is the antenna. So this antenna is used for connect an external antenna. So this antenna is essential for wireless communication. So if we want to access the Wi-Fi and Bluetooth, so this antenna is essential, right? And here we are having one reset button. If you need to reset the board after uploading the code, so you just need to click on this reset button. Okay. So if you click on this reset button, so the total system will be resetted. Okay. So next we are having one boot button here. So this boot button is used for entering the bootloader mode. So when we need this boot mode means, so which is necessary when you want to flash new firmware or new program onto the ESP32. So you need to press this boot button. Okay. So this is all about the main components of ESP32. And if we come to the applications of this ESP32, so as we already discussed, so ESP32 is main suitable for the IoT applications, right? So due to its integrated internal Wi-Fi and Bluetooth capabilities, so we can use these ESP32 boards in IoT applications like smart home automations, like smart hospitals, smart devices like that, like smart cities. Okay. So next we have another application that is wearables. So with its low power consumption and Bluetooth connectivity, So ESP32 is ideal for the wearable devices also, like smart watches, fitness trackers. So we can use this ESP32 controller. And another one is embedded systems and robotics. So this ESP32 having the high number of GPIO pins, right, along with PWM, I2C support. So these makes it suitable for controlling the motors, sensors and other components. So which is more suitable for the robotic projects also. And we have the final and one of the most important thing, that is industrial automations. So the ESP32 can be used in the industrial IoT applications for monitoring and to control the machineries and to collect the sensor data and for the optimizing the production processes. Okay, so in conclusion, so the ESP32 microcontroller board is highly versatile and powerful platform that combines both the Wi-Fi and Bluetooth, and with the advanced peripherals into a low cost and low power chip. So whether you are building an IoT application or any wearable devices or any other home automation system, so the ESP32 has the features you need to get the job done. Okay. So with this, okay, I will close the session for today. So today we covered about the introduction to embedded systems and what are the main components of embedded systems, and we have seen about different types of microcontroller families. And among those microcontroller families, so we are using the ESP32 microcontrollers. And why we are using the ESP32 microcontroller means it contains the onboard Wi-Fi and onboard Bluetooth modules. Okay, so because of those onboard Bluetooth and Wi-Fi modules, so it is best suited for the IoT applications. So one of the reason that the ESP32 has gained so much popularity because of its flexibility in supporting a different programming languages. So whether you are a beginner or an experienced developer, so there is a language that suits your needs for building projects on the ESP32. Okay, so the ESP32 controller board, because of its versatility, so it's not just due to its hardware capabilities, so but also the wide varieties of languages it supports. So which makes it accessible to different kinds of developers. So from low level system programmers to so high level developers. So whoever working on IoT application, so the ESP32 has a language to meet their needs. So let's dive into these languages and see how each one contributes to the development experience. Okay. So these are the languages so which are supported by the ESP32 microcontroller. So the first one is Arduino C, or widely used language for ESP32. So that is C or C++. So this Arduino C or C++ is the most common and widely used language for ESP32. So with the Arduino IDE. So this combination is popular because it simplifies programming while still giving. The second language is MicroPython. So for the developers who prefer higher level scripting languages, so the MicroPython is an excellent choice for the ESP32. So MicroPython is a lean and efficient implementation of Python designed for microcontrollers. And the next one is JavaScript. Okay, so this JavaScript is another language so that the ESP32 microcontroller supports. So primarily through the Node MCU and some other platforms. So these platforms bring JavaScript to the microcontrollers and making it easy to write web-based IoT applications. Okay, so this JavaScript is another language that the ESP32 microcontroller supports through the Node MCU and Espressif platforms. Okay. So this is we can use whenever we want to write the web-based IoT applications. And another one is LUA. So this LUA is a light-weighted and high-level programming language. So that is also supported on the ESP32 through the Node MCU firmware. So LUE is well known for its small memory footprint and its simplicity. And the next language is Espressif IDF. So here the IDF means IoT development framework. Okay. So now for more advanced developers, so ESP-IDF is the official development framework for the ESP32 microcontroller. So it primarily uses C and C++ only. And the next language is Rust. So Rust is a relatively new, so but it is growing systems programming language. So Rust is known for its safety, speed, and accuracy. Okay. And the final language, which is another Python-based language, so supported by ESP32. So which is derived from MicroPython, but it is aimed at making embedded development even easier. So this circuit Python is even easier than the MicroPython. Okay. So these are the different languages, so which are supported by the ESP32 microcontroller. So in our course, we are going to use this Arduino C and C++ to program our ESP32 microcontroller. Okay. Thank you, everyone.